Okay, so what you have here, I'm going to see how quickly I can do this, like in how many different pieces, is an armadillo on a ramp. Now, since armadillos curl themselves in balls, it is, of course, frictionless. Okay, it's on Earth. Let me see. I guess I should say, yeah, this should be at a right angle. It's on a slide. Armadillo's curled up on a slide at angle theta. So first things first, let's just draw the free body diagram of the armadillo on the ramp. Now, your official free body diagrams, you only want to draw forces actually acting on the armadillo. So this is going to be, of course, the armadillo is getting pulled to Earth by its weight. And just something that'll help you, always write your mg on the same side as your angle is. It'll just make your life easier. Now, the surface of this, even though there's no friction, is also pushing up perpendicular to the ramp on your armadillo. But it's not going to be as great as the weight, because remember, some of the weight's pulling the armadillo down the ramp. So, actually, let me do this. I don't want to do that in that color. Let's see. So your normal force, I'll do in blue. Your normal force isn't going to be as great as weight. Now, if you have any trouble, line a pencil up perpendicular, your hand up perpendicular to this, till you get used to doing the whole perpendicular to the ramp thing. Okay, so I'm going to draw this coming out of the center dot. Not as great. It's going to be going up. It's the force that's 90 degrees. I'm going to put F, N. Now, that's it. That would be your official free body diagram. I'm going to come over here. I'm going to draw my surface. Oh, my goodness. I almost forgot. The most important part, this is accelerating because it's frictionless and it's, hello, an armadillo on a slide. It is going to have an acceleration down the ramp. And let's make that negative down the ramp and positive, just following your convention of, stuff on Earth. All right, so what I'm going to do is I'm drawing my kind of fake free body diagram over here. I drew something representing the surface. I draw a dot. Like if you saw this on an AP test, that's all you put, only the forces acting on it. So I'm going to draw my weight over here. And then I'll do my normal force up here. Okay, same thing. Well, not a very good arrow, but you get it. Normal force. Now look, I'm not accelerating. He's not going off this ramp. He's just sliding down. So I'm going to do, that normal force has to be balanced out. So I'm going to do like I should do it dotted, but it's kind of tricky on this. I'm going to do, that's going to be something to do with weight. All right. I guess I could go ahead and just draw my whole little ramp thing here. So this would be like just kind of redrawing the ramp. That's theta. Anyway, not a very good redrawing of this, but you hopefully see that. So that's some part of your weight. And then let me do the force that's, see your acceleration, how this goes down the ramp. I'll make my acceleration up here. This is a whole other free body diagram because I'm showing components on it. You wouldn't do that on your official one. This is like pseudo free body diagram. Anyway. I think that's a little picky, but that's me. Okay, so this is also part of your weight because your weight does two things. Keeps you to the slide, pulls you down the slide. Now, the big question is, where is theta? Well, if you look at this, think about how we did like V naught, and we broke that down. Look at everything we've done. Theta's been where you don't have any arrow points. Look at where you don't have any arrow points right here. It's always that, or you can just remember it's always closest to the object. If you really look at the geometry, kind of geometry view, it makes sense. So theta goes up here. So let's look at this. So this one will be M, it's cosist, cosine theta. And this guy would be M sine theta. All right, that's it for free body. This is your free body diagram. Official free body, because you only show the forces, not the components. Oops, free body diagram. This is a pseudo FBD, or fake. I guess pseudo kind of means fake or like knockoff or something, because it has components. Okay, look, the official leak provided armadillo, provided by the AP or whatever. No components. Went over here and drew my own little messy thing. But this will give you more information. I should say cosine theta. All right.